Section 7.4 Properties of Logarithms. By the end of today's lesson, students are going to be able to expand and simplify using the properties of logarithms. We're going to start off with the product property. So the product property says if you have the log base b of m times n, you can expand it to the log base b of m plus the log base b of n. So let's look at an example of this. If I were to give you the log base 3 of 2x, 2 is being multiplied by x, so that's where I can separate it at. So I would write the log base 3 of 2 plus the log base 3 of x. The quotient property says if you have the log base b of m divided by n, you can expand it to the log base b of m minus the log base b of n. So an example of this would be the log base 5 of 4 divided by x. Since the 4 is on the top, that's the one that would come first, so the log base 5 of 4 minus the log base 5 of x. Make sure on both of these you write the bases for them. The power property says that if you have the log base b of m to the n power, you can take the n and move it out in front. So that would give you n times the log base b of m. An example of this is if you had the log base 3 of x to the 4th power, you would take the 4, bring it out in front, and then you would have the log base 3 of x. Now we're going to look how we simplify logarithms. So when we're simplifying, we're trying to condense it to make it one logarithm and then simplify it as much as possible. So I have the log base 4 of 5x plus the log base 4 of 3x. Since there's a plus sign, that means I can multiply these together using our product property. So I write it as one log, the log base 4, and then I have 5x times 3x. So 5x times 3x gives me 15x squared. You know you're done because you've condensed it to one logarithm, and then all of this is over here as its number. In our second example, we have 2 times the log base 4 of 6 minus the log base 4 of 9. Since this is a minus, we're going to have to use our quotient property. So let's first start by taking the 2 and bringing it back up as the exponent because that's our power property. So we have the log base 4 of 6 to the 2nd power minus the log base 4 of 9. All right, now we can use the quotient property. So since the 6 squared comes first, 6 squared is on the top, the 9 is on the bottom. 6 squared is going to simplify to 36, and then 36 divided by 9 gives me 4. Whenever the base and the number are the same, it simplifies to an answer of 1. Okay, this should make sense. We learned this in section 7.3. If I gave you the log base 4 of 4 and I asked you to evaluate it, you would add equals x, change it to bin form. 4 to what power gives me 4, and you know that it's to the 1st power, which is how I got an answer of 1. No, you don't have to show me all of this over here. The only reason I wrote it is to explain why I got an answer of 1. So instead of condensing it to one logarithm, we're now going to go the other way. So this time we have the log base 3 of 250 divided by 37, and we're trying to expand it. All right, before we're going to start our expansion, we're going to check out our numbers. So we have 250 and we have 37. 37 is a prime number, so I know I can't break it down anymore, but I'm going to try to break down my 250 instead. So 250, we need to break it down. So we have 25 times 10, and then we break down the 25 into 5 and 5, and the 10 down into 5 and 2. So I would rewrite the top as the log base 3, and then I'm going to put all of these together since they have the same base. So 5 to the third times 2, because 5 to the third times 2 gives me 250, divided by 37. All right, since multiplication is now happening between these two, when I go to expand it, I have to use a plus sign. Since we're dividing by 37, that's where I'm going to use my minus sign. So we write the same log in front of all of them. So I write the log base 3 of 5 to the third. It's being multiplied by 2, so we write plus log base 3 of 2. And then since we're dividing by 37, minus log base 3, 37. Last step, take the exponent, move it out in front, so our final answer is 3 times the log base 3 of 5 plus the log base 3 of 2 minus the log base 3 of 37. Now we're going to expand the log base 3 of 9 times x to the 5th. So since 9 is being multiplied by x to the 5th, we are going to separate it with a plus sign. So we have the log base 3 of 9 plus the log base 3 of x to the 5th. Okay, so just like we did before, 9 is not a prime number, so I need to break it down. So I'm going to rewrite this as the log base 3 of 3 to the second power, because 3 to the second power is 9. Now I take both of my exponents and I need to move them out in front. So the 2 comes out in front of this, the 5 comes out in front of this. So I have 2 times the log base 3 of 3 plus 5 times the log base 3 of x. Whenever the base and the number are the same, they cancel out, so you are left with 2 plus 5 times the log base 3 of x. You cannot add these two numbers because 5 is the exponent on x and 2 is just this number now. So never can you add those two numbers. That's your final answer. Now we're going to learn the change of base formula, and the change of base formula is going to let us use our calculators to find the answer. So if I gave you the log base b of n, to use your change of base formula, you would take the log of n, so since it's just the log, remember this is the common logarithm and it has a base of 10, which is what allows me to use my calculator, divided by the log of b. Our first example using the change of base formula is the log base 8 of 32. So b is my base, 32 is my number, so I would write the log of 32 divided by the log of 8. And then you're going to pick up your calculator and you're going to use it. The log, press the log button, 32 divided by log 8. Make sure you close your parentheses, otherwise you're not going to get a right number. And you should get 5/3 as your answer. So now let me show you how you get 5/3. 8 and 32, I know I could probably make them have the same base. So if I did, for instance, the log base 2 of 32 and the log base 2 of 8. So I could rewrite 32 as 2 to the 5th power. And then I could rewrite 8 as 2 to the 3rd power. Make the exponents come out in front. So I would have 5 log base 2 of 2 divided by 3 log base 2 of 2. And when the base and the number are the same, they cancel out, and that's how we get 5/3. In this example, there's no way I can make both 4 and 18 have the same base, so the only way I can do it is using my calculator. So 4 is my base, 18 is my number, so I write the log of 18 divided by the log of 4, and the only way you can do this problem is with the calculator. So you write log 18, close the parentheses, divided by log 4, close the parentheses, and you get some crazy decimal, and your answer is 2.085.